As you can see from the title of this video, this tutorial is learning to balance equations where instead of starting with the formulas themselves for the compounds, we're going to start with words from the compounds. And then the first thing we'll have to do is follow step 1, identify the reactants and products, and write formulas. And then proceed just like we did with all of the other examples that we've done. Before we can actually start to tackle some of these examples, there is something we have to discuss that are called diatomic elements. There are certain elements from the periodic table that even though they're listed as individual things on the periodic table, in reality they are not stable enough to remain that way and exist as a singular species. So what they do is they find an identical copy of themselves and they form a diatomic. They bond and create something that is still just an element, but it's two of those elements put together. And a great example of one would be oxygen, right? Anytime I ask somebody what the stuff we breathe in is, they always say O2, because they know oxygen comes in pairs. So diatomic elements are elements that exist in pairs. And the trick to diatomic elements is simply remembering what they are. So you'll hear me say this phrase a bunch of times as we push on throughout this chapter and the rest of the year. Right? But I'll ask you that you need to know what I call your Hober-Finkel's. Right? I know it sounds odd, right? But Hober-Finkel is simply an acronym to help you remember what elements are diatomics. And here's how it works. Hober-Finkel. These elements, hydrogen, oxygen, bromine, fluorine, iodine, nitrogen, and chlorine, do not ever exist by themselves whenever they're just elements. They always exist in pairs. So it's not H, but it's H2. Not O, but O2. Not Br, but Br2. F2, I2, N2, Cl2. Because when they form a bond with each other, they get stabilized, but they're still just an element. They're one element there. So we don't have atoms of these, we have molecules of these. The idea behind this is anytime you see one of these elements in word form, you have to write them as a pair. So anytime we identify something as an element, I'll always say to you, is it a Hober-Finkel? And if the answer is yes, it means you just put a 2 after its symbol. If the answer is no, you just put its symbol from the periodic table. So now we're ready to jump in and try some examples of balancing from words, now that we understand what these diatomic Hober-Finkels are. First example we have up here, calcium oxide plus water yields calcium hydroxide. So we're going to follow our steps to balancing an equation. And those steps say, identify the reactants and products and write formulas for each. Break the equation in half at the arrow and list the polyions that appear on both sides. Balance those as single units and list the other elements. Balance your polyions in elements that are not H and O. Watch for the half method in the LCF. And then lastly, balance H and balance O. So if we're going to go through, the first thing I have to do here is get myself formulas for each. So I always go through and I first ask, are they elements or are they compounds? Calcium oxide is a compound. Right? If it's a compound, I care about if it's ionic or covalent. Right? I look at this, there's no prefixes. No prefixes always means symbols and charges. So calcium is Ca plus 2, oxide is O negative 2. If we cross and reduce, you will get CaO. Moving on to the next one, water. Right? Water is a compound. Right? Now, most people know water is a common name, so you can just go ahead and list water as H2O. Third one there, calcium hydroxide. Element or compound? It is a compound. Prefixes? No. So no prefixes means symbols and charges and cross them. Ca plus 2 is calcium. Hydroxide is a polyion. OH minus 1. Cross and reduce, and we get CaOH2. So now you can see that we are to the point where we were in the beginning part of the chapter, where now you have formulas and you need to balance the equation. So we'll break this in half down the middle. Right? If you break it in half down the middle, first thing we do is list polyions that appear on both sides. Right? I see OH on the right. I sometimes will treat water as HOH to get OH on the left. But the catch is this, if I have OH on the right and I make this an OH, I have an H with nothing to counteract it over here. So I'm going to break them down into their elements. So I see Ca, H, and O, and here Ca, H, and O. Now we count how many of each we have. Looks like I have one Ca, two H's, 1, 2 O's. Over here, one Ca, 2 reaches in here and here, 2 H's and 2 O's. So you can see by writing the correct formulas, you will already have balanced this equation with simply having coefficients of 1 as you go through. Let's try another. The second one says, copper plus silver nitrate yields copper 2 nitrate plus silver. So the first thing we have to do is get ourselves formulas. So we look at copper. Copper, is that an element or a compound? It's an element. The next question is it a Hoberfinkel? Right? Is copper one of our Hoberfinkels? It is not, but you'll learn from Hoberfinkel, there's no Cu. Right? That means we just write copper from the periodic table, which is Cu. Moving on. Silver nitrate. Element or compound? It is a compound. Does it have prefixes? No. That means we'll do symbols and charges. Silver is Ag plus 1, and that's one you just have to remember what it is. Nitrate's a polyion. It ends in ATE. NO3 minus 1. So when we cross and reduce, we'll get AgNO3. Moving to the other side of the arrow, copper 2 nitrate. You say element or compound. It is a compound. Does it have prefixes? No. No dis, tris, tetras. That means symbols and charges. Copper is Cu. It's a transition metal, so the Roman numeral is telling us that it's a +2. And again, nitrate is NO3 minus 1. So you cross and reduce, and you get Cu parentheses NO3 parentheses 2. Lastly, we're working with silver, element or compound. Silver is an element. Is it a Hoberfinkel? It is not. Which means we just write the symbol for silver off the periodic table, which is Ag. Now it's a matter of balancing this thing. So we break it in half down the middle. Step 1 says break it in half and list polyions that appear on both sides. So in parentheses here I see an NO3, so there's a polyion. Does it appear on both sides? You bet. There's another one over here. No other polyions, so I just list what's left. I see Cu and Ag. And over here, I see Cu and Ag. If ever those don't match up, it simply means you made a mistake writing one of your formulas. Sometimes you'll look at nitrate and forget it's a polyion. You just use N off the table, right? And then over here you remembered it, and then all of a sudden you'll have O's on one side but not the other, and that helps you to catch some mistakes. So now we need to count how many of each we have. So it looks like I have one Cu, one Ag, and remember this is one unit, so I only have one NO3. On the other side, one Cu, because the 2 only reaches the NO3, 2 NO3s, 1 Ag. So you just take a look, this is not balanced. I have 2 NO3s on the right and 1 on the left. So I have to get there to be 2 NO3s on the left, which means we put a 2 in front of AgNO3. Now we have 2 NO3s, but we also change Ag to 2. Right? With Ag now at 2 on the left, we have to get 2 on the right, which means we'll put a 2 over there, making Ag a 2. As we go through these ones where you balance from words, right, I am showing you the long drawn out version where we balance it the old way. If you are good enough at this point to just visually jump back and forth and do it, by all means go ahead. You do not need to show me this portion here in the red. Right? We can learn to balance equations with our eyes and putting coefficients in. You don't always have to break it in half. If this is helping you get to the correct answer more frequently, by all means do it. I'll never discredit you for doing work that leads you to the correct answer. Let's take a look at one more example. Last one here. Carbon disulfide plus oxygen yields carbon dioxide plus sulfur dioxide. So as we take a look at this one, I ask myself first, carbon disulfide, element or compound? And the answer is compound. How do I know they're compounds versus elements? For the most part, compounds have 2 words and elements only have 1, right? Copper was an element, 1 word, silver nitrate, 2, compound. Copper 2 nitrate, compound, 2 words, silver 1. Here, carbon disulfide, 2 words, compound, oxygen 1, element. Carbon dioxide, 2 words, compound, sulfur dioxide, 2 words, compound. It's that simple. So, carbon disulfide is a compound. Does it have prefixes? Yes, which means we don't do symbols and charges. We simply write what we see. Carbon with no prefix means C. Disulfide means 2 S's. Moving on, oxygen, element or compound. It's an element, 1 word. Is it a Hoberfinkel? The answer is yes, so instead of it being O, it is O2. And that's all we do for Hoberfinkels. Right? If it's a Hoberfinkel, you just put a 2 after. Carbon dioxide, compound, 2 words. Prefixes, yes, so we write what we see. Carbon with no prefixes C, dioxide is O2. Similarly, sulfur dioxide, 2 words. So it will be a compound, prefixes, yes. So we write what we see, SO2. So for this one, I will not break it down at first. We'll balance it just bouncing back and forth with our eyes. And then I'll go back and show you the long drawn out to get the hang of it this way. Right, so if we take a look, according to our rules, I'm supposed to balance O's and H's last. So I have O's, so I have to save that for last. So it doesn't matter who I balance first, C or S. So say you chose C. I have 1 C on the left, I have 1 C on the right, it's already balanced. So I move on to S. I have 2 S's on the left, I have 1 S on the right. So to balance that, I would have to put a 2 in front of SO2. So now I have 2 S's, 1 C, 1 C. Now we have to look at O's. I have 2 O's on the left, I have 2 plus 2 times 2, which is 4. So I have 2 plus 4, I have 6 O's on the right. So to get the left side to give me 6 O's, I put a 3 in front of O2. And that would balance it up. So if you were able to do that, look with your eyes visually, go back and forth, and get yourself to the correct ratio, by all means, do that. Right? If you're having trouble doing that, continue to just break it down. Break this down. We have carbon, sulfur, oxygen. carbon, sulfur, oxygen. List how many of each. 1 carbon, 2 sulfur, 2 oxygen, 1 carbon, 1 sulfur, 2, 4 oxygen. Okay. According to our rules, we have to balance these two first. Carbon was good, 2 sulfur, 1 sulfur. So to get 2, we put a 2 there. So now sulfur goes from 1 to 2. And we need to recount O. So I have 2 here plus 2 times 2. So that gets me to 6 O's. So how can I get the left side to give me 6 O's? I have to put a 3 here, and that becomes a 6. And sure enough, we end up right where we were doing it with the drawn out method. So, just an added step whenever we start with the words of the compounds and the elements, so you just have to watch out for Hoberfinkel's, and whenever you see a compound, prefixes means write what you see, non-prefixes means symbols and charges and crossing. I hope this helped you out if you're having some trouble with balancing from words. If not, as always, please feel free to come in and ask for some help.